Good morning, students. In today's class, we are going to start a new chapter in which it is related to periodic classification of elements. If you see one rough diagram for the periodic classification, periodic table, that rough diagram we can draw as like this. In which this periodic table can be classified into 4 blocks. This is called S block, this is called P block, this is D block, and this is F block. Why this is S block, why this is P block, all these things in the periodic classification of 11th class we have seen. Is it okay? Now, coming to the 11th class, we have completed this S block under the heading S block elements. P block has totally 6 groups. Those are 13, 14, 15, 16, 17, 18. Under P block we have 6 groups. In that 13, 14 groups we have completed in 11th class under the name some P block elements. So S block and these 2 groups, 13th, 14th groups in P block were completed in 11th class. Remaining 4 groups of P block were completed in our term 1 exam under the heading P block elements. Remaining 4 groups, 15, 16, 17, 18. Okay, then what are the remaining 2 blocks? Those are D block and F block were remained. I hope you understood the name of our concept, name of our chapter. That is, we are going to discuss the remaining part of periodic table, D and F block elements. D and F block elements belongs to volume 1, chapter 8. In what way we have studied the P block? In the same way we have to apply here, and we have to go through this D and F block elements. Actually, whatever the equation part we have in this D and F, they have deleted the portion. So, as we are coming under reduced syllabus, our batch is related to our reduced syllabus. First, we need to see what are the topics present for us in this chapter, what are the subtopics present for us, and we are going to discuss, I am going to discuss those particular topics only. One small extra concept is also not required. Is it okay? Now, I hope you understood the total rough introduction part of this D and F. Already some blocks we have completed in the previous classes itself, and even term 1 also. So we are remained with the D and F block elements. Okay, and now our heading is D and F block elements belong to 8th chapter. But before going to the chapter directly, first I would like to say what are the topics present to us in this chapter, and those particular topics only we are going to discuss. Is it okay? Now coming to the concepts. 8.1, 8.2. Under 8.3, 8.3.1, 8.3.2, 3, 4, 9, 10, 12, 13, 14. Here between 4 and 9 we have gap, that is deleted portion. 5, 6, 7, 8. Those were deleted. 9, 10. Here 11 is deleted. 12, 13, 14. I think 15 is there, 15 was deleted. But what are the numbers I wrote? Those sub-concepts only we have. Subtopics only we have for the term 2 exam. Next, coming to 8.5. Under 8.5 we have 8.5.1, 8.5.2, 8.5.3. Okay, now just I explained what are the concepts we have for term 2, and we are going to discuss these subtopics only. Are you okay, ma? Okay, now in these subtopics, what are the topics we have related to D and F block elements? We will see now. We will go through the concept now. This is introduction part of D and F block elements. The D block of the periodic table contains the elements of the groups 3 to 12, in which the D orbitals are progressively filled in each of the 4 long periods. The elements constituting the F block are those in which the 4f and 5f orbitals. Actually, electrons, differentiating electron enters into 4d orbitals. Those are 3d, 4d, 5d, 6d. 3d, 4d, 5d, 6d. If differentiating electron enters into 3d, it can accommodate 10 electrons. So electronic configuration 3d 1 to 10, that is belonging to 3d series. If the differentiating electron enters into 4d 1 to 10, that series 4d series. Same in that way 5d 1 to 10, 5d series, 6d 1 to 10, 6d series. Like that, D block contains totally 4 series elements. First row 3d in D block, second row 4d series, third row 5d series, fourth row 6d series. In the same way, F block contains 2 rows in which the differentiating electron enters into 4f, this row fully 4f 1 to 14. Next row, differentiating electron enters into 5f. This is 4f, this is 5f. If the differentiating electron enters into 4f subshell, those are called lanthanoids. If the differentiating electron enters into 5f subshell, then those are called actinoids. Like the 2 rows we have, 2 rows have names for F block, lanthanoids and actinoids. Okay, and coming to D block, 3d series, 4d series, 5d series and 6d series. These are all depending on differentiating electron enters into which orbital. Is it okay? Now see here. F block are those in which the 4f and 5f orbitals are progressively filled in the later 2 long periods. These elements are formal members of group 3, from which they have been taken out to form a separate F block of the periodic table. The names transition metals and inner transition metals are often used to refer to the elements of D and F block elements. So often means very frequently. Frequently we will use transition elements for D block elements and inner transition elements for F block elements, other names. But one slight difference is there in definition of transition elements and D block elements. That one clearly I will explain. Before that, what is the other name for D block? Those are transition metals, and F block inner transition elements. Okay, now coming to this next thing. There are mainly 3 series of the transition metals, 3D, 4D. 3D means scandium to zinc. 4D series, yttrium to cadmium. 5D series, lanthanum to mercury. And fourth series, cerium to lutetium. Omitting cerium to lutetium. Is it okay, ma? Omitting means cerium is not there. The fourth 6D series, which begins with actinium, is still incomplete. This fourth 6D series, which belongs with which belongs with actinium is still incomplete. Now coming to this one. Here hydrogen, here helium. This is the first period. Now coming to second period. This is second period. This is third period. Up to third period, we have no D block elements. First period, second period, third period. Up to third period, we have no D block elements. Is it okay? D block elements were started from fourth period. This is fourth period. Fourth period in which D block is started here. This full block is D block. This is first series of D block, that is called 3D series. This is called 4D series. Now conclusion for you. 3D series belong to fourth period. 4D series belongs to fifth period. 5D series belongs to sixth period. 6D series belongs to seventh period. Now observe carefully. 3D series belongs to fourth period. This is 1, 2, 3. Up to 3 periods, we have no D block elements. D block elements are started from fourth period in the total periodic table. In that block, this is called 3D series, which is called first series. As the differentiating electron enters into 3D orbital, this is called 3D subshell. This is called 3D series. Fifth period contains 4D series. Sixth period contains 5D series. Seventh period contains 6D series. Okay. So our thing is 6D series belongs to seventh period. Now coming to this point, the fourth 6D series, which begins with actinium, is still incomplete. The two series of the inner transition metals are known as lanthanides and actinides respectively. See one more time. There are mainly 3 series of the transition metals. Actually, mainly three series are there. What are they? 3D. 3D series scandium to zinc. Here zinc, here scandium. Okay. 4D series. 4D series yttrium to cadmium. Next 5D series lanthanum to mercury. Scandium to zinc belongs to these elements, total 10 belongs to 3D series. Their configurations 3D1 to 3D10. Yttrium to cadmium, their configurations 4D1 to 4D10. They belong to 4D series. Lanthanum to mercury, they belong to 5D series. And coming to 6D series, cerium to lutetium except cerium. That means actinium to lutetium. Here Y is equal to yttrium. CD means cadmium. La lanthanum. The elements following lanthanum are called lanthanoids. Next, AC actinium. The elements which follow actinium are called actinoids. Lutetium, Lu. Scandium, Sc. Okay, these are the elements, abbreviations I told. Actually, 3D series, scandium to zinc. 4D series, yttrium to cadmium. 5D series, lanthanum to mercury. 6D series, actinium to lutetium. Is it okay, ma? Now, under the periodic table, they kept 2 separate rows. First row in which differentiating electron enters into 4f, which is called lanthanides. Second row, in which differentiating electron enters into 5f, which is called actinides. Now coming to the explanation. Series of the inner transition metals are known as lanthanides and actinides respectively. Strictly speaking, a transition element is defined as the one which has incompletely filled d orbitals in its ground state or in any of its oxidation states. Zinc, cadmium and mercury of group 12 have full d10 configuration in their ground state as well as in their common oxidation states, and hence are not regarded as transition metals. However, being the end members of the three transition series, their chemistry is studied along with the chemistry of the transition metals. Is it okay? Now this complete thing we will consider it now. Let us see the explanation for transition elements. Transition elements are the part of D block. These are also D block elements only. Maximum we will say D block elements are also called transition elements only, but very thin line of separation is there. That separation we will see now. Okay. Now what is the definition of this transition elements? The elements which contain incompletely filled D subshell configuration the elements which contain incompletely filled D subshell configuration in their elementary form or in their most stable oxidation state are called transition elements. The elements which contain incompletely filled D subshell. This is not half filled incompletely filled. Incompletely means D1 to D9. These total configurations are called incompletely filled configurations only. Incompletely filled D subshells. Only one completely filled D subshell, that is D10 configuration only. Are you getting my point? Only one completely filled D subshell, that is D10 configuration only. So the elements which contain incompletely filled D subshell configuration in their elementary form or in their most stable oxidation state. For example, most stable oxidation state of copper is +2. Most stable oxidation state of copper is +2. Normally, copper in its elementary form means neutral form. Configuration of this copper is argon 4s1 3d10. Argon 4s1 3d10. This is the electronic configuration of copper in its elementary form. Okay, in that elementary form, copper has completely filled D configuration. In that elementary form, copper has completely filled D configuration. But we asked that R, meaning what is the stable oxidation state of copper? Cu+2. In Cu+2, 2 electrons must be lost from copper. Then we will write the electronic configuration of Cu+2 as argon 4s0 3d9. Observe, in the stable oxidation state of copper Cu+2, the Cu+2 does not contain completely filled D configuration. Completely filled means D10. But here in its stable oxidation state Cu+2, it has D9 configuration, 3D9. This is incompletely filled D subshell. So what is the definition of this one? Transition elements or metals. The elements which contain incompletely filled D subshell configuration in their elementary form or in their most stable oxygen states. In any one form, if they have incompletely filled configuration, immediately we will say the type of substances or metals are called transition metals. So copper has completely filled configuration in its neutral form or elementary form, but it has not completely filled D subshell in its most stable oxygen state, Cu+2. So copper is coming under transition metal. Don't think that Cu+2 is a transition metal. Okay, whether Cu+2 has incomplete configuration, D configuration, or copper has incomplete D configuration, copper only it is called transition metal. Is it okay, ma? Once again, the elements which contain incompletely filled D subshell configuration in their elementary form or in their most stable oxygen states are called transition elements. That's why copper is not a D block element. Copper is a transition element. Along with that, it is a D block only. All transition elements are belonging to D block. But all transition elements are not D block elements. Sorry for this one, ma. All transition elements are D block elements only, but all D block elements are not transition elements. This is very much clear. One more example I will take. By that we will conclude this one, ma. This definition. Before that one, I hope you understood this definition. The elements which contain incompletely filled D subshell configuration in their elementary form or in their most stable oxygen states are called transition elements. Now coming to the one more example, zinc. If you see zinc in its neutral form, its configuration is argon 4s2 3d10. What is the electronic configuration of zinc? Argon 4s2 3d10. This is the neutral form of zinc. In this, it has completely filled D configuration. Okay. Now, most stable oxygen state of zinc is zinc+2, Zn+2. In this Zn+2, 2 electrons from 4s only will be lost because outermost shell is 4s. Outermost shell is 4th shell. In that, electrons are present in 4s. So, when we are going to remove the electrons, first outermost electrons must be removed. That's why these electrons must be removed. So, Zn+2 configuration is 4s0 3d10. Argon 4s0 3d10. In its most stable oxygen state, in its neutral form, zinc has 3d10 configuration only. It has no incompletely filled configuration of D subshell. That's why zinc is not a transition metal. If it has completely filled configuration in any one of its form, if the element has completely filled D subshell configuration in any of its form, neutral form or in its most stable oxygen state, then it is not coming under transition element. So zinc is not a transition element or transition metal. Simply we will tell zinc is a D block element only, but it is not a transition metal. So that's why I wrote here the point. All transition elements are D block elements, but all D block elements are not transition elements. See, zinc is a D block element, but it is not a transition metal. Okay? This is the introduction part and the explanation, and mainly what is the definition of this transition metals. I hope you are clear. Is it okay, ma? Now we will see what about the next point. Strictly speaking, a transition element is defined as the one which has incompletely filled d orbitals in its ground state or in any one of its oxygen states. Zinc, cadmium and mercury of group 12 have full D10 configuration in their ground state as well as in their common oxygen state. See, stable oxygen state or common oxygen state, that is same only. Okay, and hence are not regarded as transition metals. However, being the end members of the three transition series, their chemistry is studied along with the chemistry of the transition metals. Along with transition metals, here itself we are going to study zinc, cadmium, mercury. Observe. 3D series scandium to zinc. Here zinc is there. Here cadmium. Here mercury. These are the end members of the transition metals, which are coming under D block elements. Okay, these things also we are going to study in this D and F block. The presence of partly filled d or f orbitals in their atoms sets the study of the transition elements and their compounds, apart from that of the main group elements. However, the usual theory of valence as applicable to the main group elements can also be applied successfully to the transition elements. How normally we are applying properties to the S and B block elements, like that here also we can apply, but slight differences are there. That one in the properties like that we will study. Okay, various precious metals such as silver, gold and platinum and industrially important metals like iron, copper and titanium form part of the transition metals. Okay, in this unit, besides introduction, we shall first deal with the electronic configuration, occurrence and general characteristics of the transition metals elements, with special emphasis on the trends in the properties of the first row, transition metals, and the preparation and properties of some important compounds. This will be followed by consideration of certain general aspects such as electronic configurations, oxygen states, and chemical reactivity of the transition metals. This para is going to tell that in this chapter what we are going to study regarding D and F block elements, we have seen that one. Now we will enter into our next main topic. Next, that is D block. First we will discuss the D block. After that we will come across with F block. Is it okay, ma? So our topic heading itself D and F block elements. Now we are entering into D block elements. Coming to the explanation of these transition elements, in bracket they kept D block. D block is nothing. Transition elements are not included with zinc, cadmium, mercury. But anyways, we are going to study all these things we have seen in the introduction part. Okay. Position in the periodic table. 8.1, it is there. Okay. The D block occupies the large middle section flanked by S and P block elements in the periodic table. In between S and B block elements, we have D block elements, that is the position. The very name transition given to the elements of D block is the only because of their position between S and P block elements. While we are moving from or transiting from S block to P block, we got the properties of these elements. That's why these are called transition elements. Like that they will say. The very name transition given to the elements of D block is only because of their position between S and B block elements. The d orbitals of the penultimate energy level in their atoms receive electrons, giving rise to the three rows of the transition metals, that is 3d, 4d and 5d. The fourth row of 6d is still incomplete. The series of the transition elements are shown in table 8.1. In this 8.1, I will show once again. Before that, what is meant by penultimate energy level? Okay, ma? Now, electronic configuration of calcium. Electronic configuration of calcium is argon 4s2. Electronic configuration of calcium is argon 4s2. What is outermost shell? 4. Fourth shell. So calcium 1, 2, 3, 4. Argon up to 3 it is completed. Next outermost electrons are present in fourth shell. But coming to scandium, Electronic configuration of scandium is argon 3d1 4s2. That means 4s2 3d1. What is the electronic configuration of scandium? Argon 4s2 3d1. After completion of the outermost shell, fourth shell, next electron is entering into third shell. See, after entering into fourth shell, electrons are entering into third shell. This is valence shell, which is called ultimate. This last shell is called ultimate shell, or valence shell, or outermost shell. All are same only. Okay, just the orbit which is before the outermost shell, that is ultimate shell. This is called last but one, penultimate. This is called penultimate shell. They told that one only. See, electrons first enter into fourth, that is outermost shell. Next electrons are entering into inner shells. 3. That is called penultimate shell. So that's why they told penultimate. See ma? The 3d orbitals of the penultimate energy level in their atoms receive electrons, giving rise to the 3 rows of the transition metals 3d, 4d and 5d. However, 6d is incomplete. The fourth row of 6d is still incomplete. The series of transition elements are shown in table 8.1. In the table 8.1 they have shown these details. See. First series, scandium to zinc. Atomic number 21 to 30. 4s2. Exceptional configuration of chromium and copper we have seen in the previous class also. 3d. Scandium 1, 3d1, titanium 3d2, like the 3d1, 3d2, 3d3, 3d5, 3d5, 6, 7, 8, 10, 10. Okay, this is the configuration of first series of D block. Outer electronic configuration of the D transition elements, ground state. Next, that is 3d series. This is 4d series. See the 4d. 4d 1 to 10. What are the elements? Yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium. Okay, this is the second row. This is third row. Third row. Second row contains 4d series. Third row contains 5d series. Lanthanum to mercury. Lanthanum to mercury. Next, 3d, 4d, 5d, 6d. See, 6d 1 to 10. (6d 1 to 10). 7s outermost shell 7s. 6d is penultimate. Ultimate shell, penultimate shell. Actinium to, this is not completed one ma. UUB. Unbayam. Unbayam. UNBIUM. Okay, this is not completely discovered. That's why only they will tell that incomplete period. This incomplete period of group D block. These are the 4 series. First series, second series, third series, fourth series. First series is called 3D series. Second series is called 4D. Third series is called 5D. And fourth series is called 6D. Is it clear? This is the information about 8.1, position in the periodic table. Next we will come across with the electronic configuration of the D block elements. In general, the electronic configuration of these elements is n minus 1 d1 to 10 ns 1 to 2. Why we'll write like this? Observe here. I will write one series scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, zinc. Scandium configuration is 4s2 3d1, titanium 4s2 3d2, vanadium 4s2 3d3. Coming to chromium, exception configuration is there, that means 4s1 3d5, manganese 4s2 3d5, iron 4s2 3d6, cobalt 4s2 3d7, nickel, copper 4s2 3d8, copper 4s1 3d10, exceptional configuration of copper also, zinc 4s2 3d10, zinc 4s2 3d10, this is 4s1 3d10. Along with S2 it will show 1 also in S element, in S subshell. That's why they wrote the configuration, general configuration. See, if you think this has N, S 1 to 2, because some elements have 4s2, some elements have 4s1. So 1 or 2, anything we can write according to the exceptional configuration of that element. Okay, ns 1 to 2, before that n minus 1, d 1 to 10. N minus 1, why did I write? This is penultimate shell. Here 4 is there, means here 3. Like that, n minus 1, d 1 to 10. N minus 1, d 1 to 10. See, ns 1 to 2. Why did I write ns 1 to 2? Some elements have exceptionally 4s1, like chromium and copper. Copper also 4s1 3d10, chromium 4s1 3d5. That's why they wrote ns 1 to 2. Otherwise only they have to write that ns2 only. But here sometimes 4s1 is there, sometimes 4s1 3d10, like that we have. So this is the general electronic configuration of D block fully. Here if you get 3, here you will get 4. Here if you get 4, here you will get 5. Like that we can write the configuration generally easily. Is it okay? This is the general electronic configuration. The n-1 stands for the inner d orbitals which may have 1 to 10 electrons, and the outermost ns orbital may have 1 or 2 electrons. However, this generalization has several exceptions because of very little energy difference between n-1 d and ns orbitals. When we move away from the nucleus, first shell and second shell energy gap is high. Energy gap present between first and second shell is high. Second shell and third shell energy gap is reduced. Third shell and fourth shell, that energy gap again slightly it is reduced. The energy gap between 1 and 2 will not be there in between 2 and 3. That 2 and 3 energy gap is not there in between 3 and 4 also. Like that, while we are moving away from nucleus, these energies of the orbits are little bit closer to each other, and coming to this third and fourth, they are somewhat nearer by each other. That's why 3D, 4S energy gap, energy levels are not getting separated by very much high level. Because of that, electrons can jump from one energy level to another energy level easily to get stabilized. That's why we can write 4s1 3d5. S electron can be jumped to 3d electron easily because the energy gap is very low. When the energy gap is very low, electron can jump from one orbit to one subshell to another subshell somewhat easily only, as the energy gap is very less. Is it clear? Half and completely filled sets of orbitals are relatively more stable. See, however, this generalization has several exceptions. because of very little energy difference between n-1d and ns orbitals. Furthermore, half and completely filled sets of orbitals are relatively more stable. Complete configuration and completely filled configuration and half filled configurations are more stable when compared to other configurations. That explanation also we can give. A consequence of this factor is reflected in the electronic configuration of chromium and copper in the 3D series. Consider the case of copper, for example, chromium, for example, which has 3d54s1 instead of 3d44s2. The energy gap between the two sets enough to prevent electron entering the 3d orbitals. Similarly, in case of copper, the configuration is 3d10-4s1 and not 3d9-4s2. The outer electronic configuration of the transition elements are given in table 8.1. This is the explanation about 8.1, 8.2. General electronic configuration. 8.2 is not completed. Further it will be continued here. Okay, in which I will explain in the next class. From here onwards, topic wise clearly I will explain what are the topics present for us. Those topics only we will concentrate, and after completion of this chapter we will go for the revision. Is it okay? General electronic configuration, why did we write n-1d, n-1d 1 to 10, ns 1 to 2. The energy gap when we move away from nucleus, the energy gap is getting less. Okay, because of that electrons can be transferred from one subshell to another subshell somewhat easily. Because of that 4s electrons can be jumped to 3d somewhat easily. That is the thing we can say. Along with that we can write one more reason, that is half-fill configurations and full-fill configurations are more stable when compared to other configurations. According to that, 3d5-4s1, this configuration is more stable when compared to 4s2 3d4. This configuration is not stable. That's why chromium is converted to this configuration immediately, and even copper also changed to this configuration easily because of less stable nature. Is it clear, ma? This is the introduction part and general electronic configuration of these elements. And in today's class, what are the things we have seen? In today's class, we have seen that what about the D and F block elements? Previously, what are the topics we have completed, and what is the remaining part of periodic classification? That one we have seen. And what is our heading? D and F block elements. In the D and F block elements, some sub topics are also there, in which some topics were deleted and some topics only we are going to discuss. Okay, we will concentrate on the topics which we have. Those topics I mentioned already in the starting of the class. Those numbers neatly note down, and according to that only we have to prepare. This time weightage for D and F block elements is less when compared to P block elements which we have written for term 1. That's why slightly no problem. Is it okay? And equation part is also not there like P block, so we are in safe position only. Okay, concentratingly listen to the class carefully, and according to that, if you do hard work, there is a easy chance to get full marks for you. That is the thing. Okay, after completion of the introduction part, we have seen that transition elements position and general electronic configuration we have seen. Are you okay, ma? This is about today's class and introduction part related to this D and F. We will continue this class in the next class. Thank you all. Have a nice day.